In this video, I'm going to show you the Egyptian grid method for modeling multiplication of multi-digit numbers. So the first problem we're going to look at is multiplying 14 by 26. And in this method, I'm going to write the first value across the top, and then I'm going to construct a little grid like this, and we're going to go 26. And I'm making it large enough just so that it's clear to see the different steps. I usually provide students with a grid that's been printed out for them so that they can fill in the values more quickly and easily and not have to spend time drawing the grid. Okay, so we have 14 times 26, like that. Now, each of the quadrants in this grid represents one of the multiples. So I've actually got, this 1 is a 10. So 1 times 2, the result is 2. And I'm going to draw in a little diagonal grid here, a little line, and the 2 goes below that line. 4 times 2 is 8, less than 10. 4 times 6 is 24. So this time with my diagonal line, the 2 of that 20 goes above the line and the 4 goes below. So 24. And then 1 times 6 is 6. And I could put zeros as placeholders in above the lines here if I wish. At this point, the addition that happens to figure out what the different numbers are in the different positions is a diagonal move. So I'm going to go diagonally down from the right to the left, following those lines that I just drew. So in my ones place, I have 4. That carries right down. In my tens place, I have 8 plus 2 is 10 plus 6 is 16. So I'm going to write the 6 and I'm going to carry that 1 above the line. And I keep going diagonally. 2 plus 1 is 3. So I've got the answer to that multiplication is 364. And I changed color just to show that that 1 came from the addition of all these 10s together. Okay, we're going to do another one. 35 times 78. So again, it's a 2 by 2, 2 digit by 2 digit. So I'm going to start with my little grid like that, diagonal lines. So 35 times 78. You can consider you could put a little x here for multiply. Now, 5 times 7 is 35. 3 times 7 is 21, so the 20 goes above the line and the 1 below. 3 times 8 is 24. And 5 times 8 is 40. And then again, we're going to add, going from the top right to the bottom left. So in the ones position, I have 0. Change color here. Okay, so it's reading like this. In the tens position, I've got 5 plus 4 plus 4. That is 13. So I'm going to put 3 and carry 1 up. In the hundreds position, now I've got 3, 4, 5, 6, 7. So in each case, the numbers come down like this. And then that leaves me with 2. So 2,730 is the answer for that multiplication. All right, let's do one with a few more digits. So we're going to go 104 times 52. So a 3 digit by a 2 digit this time. So this helps with linking to using a lattice or an array and connecting arrays with multiplication. The number of digits is how many columns and how many rows. 104 and 52. This is also called lattice multiplication. Okay, and then I put in my diagonals. And you'll notice I did not put any diagonals in this center spot here. I can, it doesn't matter. But the 0 isn't going to give me a value. 0 times anything is 0, so it's kind of not necessary. Okay, so 4 times 5 is 20. 2 above the line, 0 below. 2 tens, 0 ones. 4 times 2 is 8. 0 above the line. I'm going to put in some placeholders here. 0 times everything's 0. 1 times 5. And 1 times 2. So the units go below the line, tens above the line. And then we just read diagonally each of the values. So I have 8 ones, I have 0 tens, I have 4 hundreds, and I have 5 thousands in that answer. All right. What I like about this method is that it scaffolds up nicely. And I'm going to give you an example of that using binomials. So if you are looking ahead to algebra, so this is binomial times a binomial, so 2 by 2, similar to the ones above. X plus 3 and x plus 4. So I'm going to put the diagonals in again. And in this case, they don't refer to tens. It's just to keep the values organized. So 3 times 4 is 12. I'm just going to write that down here. 3 times x is 3x. X times 4 is 4x. And x times x is x squared. So in this case, what I'm left with when I read down here is I've got the constant term is 12. 2 linear terms end up aligned with each other. 3 plus 4x is going to simplify down to 7x. And then x squared. Okay, so that's what it looks like with a trinomial. And we'll do one more just as a bonus. Let's do x squared plus 3x plus 4 times x plus 2. So trinomial times binomial. So I'm going to have 3 spaces across and 2 down. X squared, 3x, 4, x and 2. And I'll put in my diagonals. Okay. 2 times 4 is 8. 4 times x is 4x. 3x times 2 is 6x. 3x times x is x squared times 3. X squared times 2 is 2x squared. X squared times x is x cubed. So what I've got here is it shows me in the diagonals that my end term is going to have 4, my end polynomial is going to have 4 terms in it. It will have a constant of 8, followed by 10x. Then I've got 5x squared, and I've got x cubed, like that.